I'm Gil. Thank you for coming today. We're opening a new season on the webinars. This season, believe it or not, is going to be about AI. I've done some webinars that are all on my YouTube channel, recordings all there about how we can use AI as part of our testing. But the next series of webinars starting today is going to be about testing products that involve AI in them, which is kind of interesting, cool, and sometimes even if your product that you're testing is not there, let me assure you it is, not in the way that you're thinking, but because the developers is always generating code that they don't know what's going in there. So in terms of predictability or unpredictability, it's still there. But we're not going to talk about this today. We're going to talk about testing products that involve call a model, get a response back, and do something with it. Talk about the concepts of testing this thing. Now, this is like an introduction. So I will show examples, and I will show examples with code, God forbid. But everything that I'm going to talk about today is sort of introduction of the concepts, and also whatever I'm going to show you today. I want you to remember that code and automation, except for maybe a little bit, is what comes next. So everything that we're going to talk about today, especially how we're thinking about testing a system and the techniques, are mostly definitely human. So it doesn't require automation, although I think one of the things that we'll need as we move forward is more and more and more automation, only not the kind that we sort of used to. So like I said, welcome. I'm Gil. I'm the one with the coffee. And I'm a trainer and a consultant. And I work with testers and developers who want to make their software better. And obviously, the more I work with people over the last few years, it's about working with the people and their little genies, big genies, depending on how much progress they made, the genies. I have a site, testingguild.com. I have a YouTube channel, Testing Guild, that you can go and watch all these webinars and other videos that I put on a weekly basis, I think. And basically, if you require some help in your efforts in testing, development, AIing, let me know. Maybe I can help you. Yeah, that's a lie. There isn't a workshop for that yet, but there will be. So I'm working on workshops for testers and developers who use AI as part of their job, how to use that effectively. Let's even say safely. So watch out for some news soon about the workshops that's going to be out. I hope you'll find them useful for your profession. So let's start with the elephant in the room and how we used to do some testing and how things have changed. So we have like a system calls out and defines a prompt, calls out something, a model outside, model returns an answer, and the system's supposed to do something with it. Now, the main thing is that it's going to be a different answer every time. Now, what does that mean? It could mean like many things, like if you're looking from the outside, the whole system, you may not know what's going on inside it. If things are working well, maybe you shouldn't even know what's going on inside it. But we have to take into account the non-deterministic, let's call it personality of our subject. So how do you test something like that? And if we take it like one step further, how do you test it consistently? Because if you've done this, right? Everyone as a user have done this, even with ChatGPT or something like that, even outside the work. Ask it the same question twice, you get already a different answer. And if we're thinking automation, we're talking about a repeatable process, and we want to see how this thing is going. But even before we get to automation, we need to at least create some kind of concept of what we're doing and what we need to do, and how is it different than what we did until now. So I want you to take you back to what we're supposed to do. We're supposed to, as testers, look at the system, push some inputs into there, look at the outputs, and say, well, does it work? Well, basically, what we're doing really is looking at it and basically collecting information. We're learning about it and giving this information in as much confidence as we can. This is what we've learned about the system. And the stakeholders that we give the information to will do something with it. Hopefully, something good, like release a system, release a version, not release it because there's a bug, go fix the bug. But this information has to come in the same way that it has come until today, right? The same, at least in the same confidence that we want to, because based on that, decision will be made, and we want the right decisions to be made. So this basically the expectations from us, our role in that really doesn't change. We're still learner of the systems and reporters of what we learned. So this doesn't change. What does change a bit is that how we look at results. And it's a kind of a shift in our mindset that we're looking instead of good for good enough. But that's a bit of a lie too, because we've done this. Like every good that we have, it's good enough. Like you release a system with bugs, right? That means that it is not good, but it is good enough. So we do this already in a way that we're kind of judging whether what we see is good, is working, and it is good enough really. So again, this doesn't change, but we kind of switch that we need to do, because we're used to look like, again, going back to either manual testing or automation. You look at the result, you expect something. If it's there, it's working. If it's not there, it's not working. But again, is it really not working? Is it not working? But we'll do the analysis, we'll find out what's happening there. But we will need to redefine this in a different way. So what are these things that we need to think about? So if things are not going to repeat themselves, first of all, we need to think about the things that are going to repeat themselves. So we will look at properties of answers in the system, the invariants, things that are not going to change. And of course, I'll show examples very soon. And as long as these properties are maintained, we can say that the system is working. So instead of looking like an example and a result of that, we kind of look at sort of in a different way. So we'll probably build something around it. Another thing that we'll need to do, which is, again, something that we did, but it was a lot more apparent to us, is that when we had an assert x the result x results equals 5, that meant, well, 5 works, all other things don't. So we'll need to replace this kind of condition, the assert, with something else. And if you think about the 5, in our very big story, the 5 is sort of a border, and it's a boundary. Inside this little line that is 5, everything's okay. Outside it, things are not okay. We kind of lived with that for a while, and we were okay with that. But with testing things that non-determinist, then we'll have to think about them differently. So we'd try to create this boundary that within it things are, we can perceive them as good or working, and outside they're definitely not working. So there are going to be some gray areas, but at least we'll try to build this kind of boundary around our system during the test that we're running to see what is actually working. So we'll look at that as well. So I told you what everything that we're going to do starts with manual testing, because obviously this is the first thing that we'll do. Automation comes next, not always, like regular testing, but we need to think in a way that if there's no human to watch the result, can we say, is it good enough still? Now, with automated tests, this is what we did. We taught the computers, the software to check x equals 5, whatever x is, and it looked at the x and compared it and said, okay, x is 5, therefore it is working. We want to at least try to do this in a way that we can teach a machine to do this. So even if we're not talking about automation as the first step, we still need to do this, and there's a reason for that. The more Okay, we are already testing really complex systems. This is not going to way because they're going to be even more complex. The only way that we know to fight this kind of complexity until today was more and more automated tests. We were using them as a safety net, as a regression suite to tell us, well, these things are still working, and maybe at least these things are still working while we're focusing on the new stuff or things that we don't control, stuff like that. Now, we have a lot less control on the system. system became even more complex, sometimes in ways we can't even describe, because everything that's happening inside not the product itself, but the model is a black void we can't look into. We can control our stuff, and we talk about that, but everything there is like magic, which creates a lot of complexity we don't even understand in the entire product. So again, we'd like to have as much automation to at least tell us, well, the things that we can look at and we can control and we can quantify are still working, because things are going to get more complex in ways we can't even think of. So the automation part is maybe not the first thing that we do, but we need to think about, well, if we're going to develop this product and test it for a long time, we need to think about covering this with automation that we trust. So this will not go away. I want to mention something else which is sort of emerging in this kind of software, is that testers are not just testers anymore. Because what happens is that our product, our system, our code, we'll talk about ours and us and them in a minute. Our code creates some kind of prompt which, being sent to the model returns the return, we'll see the outcome of this answer. So this creates a loop, a feedback loop, that puts testers in an interesting position, or really the first time in history, software history, when they actually can say, well, let's change the prompt and see what happens. Which is, if you think about it, it's kind of similar to something else that developers do, which is refactoring. So think about what is refactoring. Refactoring is a way that, it's not exactly like that, but it's an analogy for that. What is refactoring? Refactoring is changing the code without changing the functionality. How do we know that we didn't change the functionality? We have tests to prove that. It's regular refactoring. What we're trying to do, and developers, testers, everyone working on the product, is at least get the prompts, not multiples, that we're going to send to the model to bring something that is optimized in different ways. It's the right answer, it's something that we can trust, it's something that we can test consistently, all these kind of things. And testers are introduced into the loop where they can actually change the prompt and play with it and optimize it to narrow the boundaries that I was talking about, to make this not only working, but working better and working towards the good enough. So I think this is something that I saw already, and and I think we'll see more of that, testers are going to go into the loop of really development, because they'll be in the feedback loop of optimizing the prompts. So if you've done this like as a developer, like created something and like you didn't like it, optimize the prompt and stuff like that, working with agents or something like that, this is the cycle that I'm talking about, and I think about the testers are going to enter this cycle because they're more attuned to this process of feedback than developers are. But we'll see. I want to talk about colors and parts of our code. First, let's talk about the code. And we have kinds of our code and theirs. There's the model, which is, like I said, a black hole. We don't know we know what we're sending. We know what comes out. We can look at it. We don't know what happened inside. And we know that if we send it into another black hole, something else will come out. And if we're sending the same prompt to the same black hole, something else might come. So that we don't have any control about, but we have control on our code, my code. And this is like the regular testing of old, only this is part of IntelliJ, the code in the product. So we're not thinking about testing this in regular terms like testing a system. This is like what I call the experience, test the entire system. But there are two things, the scaffolding and the plumbing, which is our code, and we can test them. I'll show you examples. What is a scaffolding? This is the logic we have in our code. We call the model, got a response, we do something with it. The do something with it is up to a point deterministic. It's regular code, the code that we've written until 3 years ago. We can test it in different ways. There are methodologies like that for that, unit testing, integration test, stuff like that. We may not know today, but they are learnable because we have like 35 years of experience of testing these things. So this is like the code that I can test, excluding the model itself. My code in the middle is the one that actually calls the model And you can think about it as the plumbing. This is like the wrapper, the thing that collects the information and maybe creates the prompt and maybe calls the model and maybe do some error handling if something comes back. Again, this is our code. We can test it. Again, developer tests are good for that. We can mock the model and check what our code does. And the final layer is, of course, the whole system. Now, why am I talking about this? Because I'm talking about testability all the time. What's the goal? We want to report as much as we can about the system in as much confidence as we can. If we test this code, left-hand part, the scaffolding, the plumbing, as much as possible, unit tests, automated unit tests, all kinds of tests that we do, API tests maybe, all the things that we do here, we'll know, assuming that the tests are passing, that this code, this part of the product is working. The one that we don't know anything about is still going to be remaining a mystery, but at the end we kind of say, well, we tried these things and they don't work, right? But we know that the parts leading to these things going into the model do work. So using this kind of separation, the layered approach, and this is not just a layer in the slide, a layered approach in the code and testing approach to these layers means that we can raise the confidence of what we're going to report. So we're not running away from testing the entire product, like this is mostly the main thing, but we're trying to raise our understanding and our confidence that at least our code, the one that the developers wrote, works as expected, because we can blame the model after that, or try something with the prompts, or maybe remember, this is what we're seeing. We're getting this to the stakeholder to say this is not good enough. Okay, what does it mean? Let's play with the prompts. It's a decision. It's not more investment in tweaking prompts. It's good. We're doing still what we need to do. So we again, the goal didn't change. We need to report as much as we can in as much confidence. And testing these bits, usually by developers, is like crucial, let's call it. It's very important. Okay. But this doesn't happen by accident. Code needs to be written like this in order to be what we call testable. I remind everyone who hasn't seen my testability webinar, there is something like that. Testability is not a binary thing. It's not something that is either testable or not testable. Especially when you look like at a product that calls a model, obviously it's testable, but there are levels of testability. So this needs to be designed up front in order for us to be, for the developers to test these things and tell us, well, these things are working. And maybe us, the testers, can review the test with them and say, this is okay. Oh, you missed out this kind of case. We want this like wrapped shut in order to say we can trust this. But if we see like a spaghetti code from the beginning, it's going to be hard to do that. So it has to be designed in. Okay, so let's see some examples. After all, we didn't come all the way just to see memes, right? So what I'm going to show you is basically something that I'm going to run next week for the first time. This is PyCon, Python conference, and I'm going to run a workshop about, usually for developers, we'll see who actually comes, for how to build an API test agent, really. It's like teaching how to build an AI agent with the concept of API testing. So I kind of stripped down from it a lot for what we're going to do today, but the main concept is still there. So let me show you. Okay, so let's look first at what does the patient look like? So we have a sort of agent, very limited one. It doesn't do much, but it will serve as example that we need for today, which is this is like a class, which of course I'm showing it in Python and PyCharm, and I'm using Gemini. You can see that. But what we're going to talk about today is like model agnostic and language agnostic, because you have everything. So basically you got, you sort of connect to the model, get the API key in, configure some things like the token, stuff like that. And this is the main method that we're going to concentrate on for the beginning, which is get testing suggestions. You get an endpoint, something that includes the method, path, and info. I'll show you an example in soon. And the prompt that we're testing, or we're actually not testing, we're sending, generate 5 specific test scenarios for the API endpoint. create a list for me. The thing calls a private method called generate content, which actually is the plumbing. Okay, which it's a wrapper for calling the model, but it's separated from the thing because after we get the response here, there's some code, some logic in the agent that strips that and can create a list of suggestions the way we intended. So, and it leads up to 5 of them. So this is really what I call the scaffolding. This is the logic that we have around the code, but we can test it separately, or we'd like to test it separately. We can't really. Okay, if you know a bit about unit testing, this is part of a function. This would be easier to test if it was like a complete function, but this is what we have today. Okay, so I'm gonna start with the developer test because this, like I said, this is like necessary, required. And what does a test look like? What do we test here? Again, this is like something that we expect the developers to do. And if there are no developers with us today here listening to this, then us, the testers, needs to have a very, hopefully not too long conversation with them explaining what we need to do. So this is like a test that they can write. It doesn't call the model because we mock it. We sort of return something. Actually, we actually do this. We mock the model. We will mock the model response. We don't actually call it. We said, what? Given that this is something that comes out, we can, and we mock it. Then we expect this is the list to come out. So basically, this is like a real sort of unit test, which is good. This tells us that the logic that creates the list, if we are creating the list, works. This is again, these are the first steps of telling, well, something is good enough. So this is the scaffolding. There's the other part, the plumbing. So again, let me show you again. So we're talking about this method here, which kind of actually calls the model, generate content. This is the one that actually calls the model and gets a response. So we want to make sure that at least the error handling works, for example. So let's look at that using PyTest here. Again, not calling the model, mocking the response. And I can do call the method directly. And this time I'm not mocking the generate content. I'm actually calling the call model API method. And so it's like testing the small method, which I can do in Python. Other languages, it would be harder still, like Java or C#, because this is a private method. But okay, technicalities. Developers can do everything. So if the answer is, I'm sorry, Dave, I can't do that, I'm expecting that method to return an empty list. Also, from the point of view of the public method, it's going to be the same. So here I'm calling the main method, get testing suggestions, still mocking the model, and this is what I want to see from the outside. These two basically are testing the same thing, but maybe there's something else with the logic. So I'm still testing parts of my code. I want to make sure that this actually works. And I can check that if what here's like something like an exception is thrown, something like that. Our code something does something that to deal with the exception with the surprise does. Again, these are like basic unit tests. This hasn't changed. So yeah, let's leave developer tests behind because these are for the developers. Let's talk about our tests. So I told you from here on, we're talking about, I think most of the examples are actually calling the model. Here is get testing suggestions, actually calls the model. Yeah, that's what I ran before we even started. So let me show you. So what am I checking here? So I'm giving it a get method with users ID to do's. And the description returns the to-do list for a specific user. And remember what I asked is for test cases or test suggestions. So I got something back, and this is what it returns. Okay, this is the print. Okay. Okay. Now, yeah. And let's talk about this line. Is it good? Well, I asked for 5. The prompt asks for 5. Makes sense that I will check that this is 5. Okay. But will it always return 5? And that's the answer that we're trying to find out. And your experience may differ. It's not going to be 5 every time. What is it going to be? Well, we can say that if it's between 3 and 7, it's going to be more resilient. This makes sense that let's assume for a minute that it's 7 here. If we're saying, well, 5 is great, but between 3 and 7 is good enough, then we might want to write that at least what makes things good, what makes the system work, is it returns something between 3 and 7 cases. Why? Okay. Also, you can do another type of, I'm not even calling it sanity. It's like the minimum of the minimum that says this is working. Okay, so you can say, well, what is a suggestion? Well, it's a string, and it has to have more than 10 characters. It's a suggestion, right? It's a sentence. And we'll look at the further the examples. We'll get more and more about the content itself. But we kind of try to shape what is a good answer and what is not a good answer. Because we're always thinking, well, what makes a wrong answer? Okay, so why did I put 5 here? Well, I can look at the code. Remember, yep, yeah. This is the end of the method that I'm testing. And what this says in Python is that out of all the suggestions, give me the first 5. So this is deterministic. It will never be, unless there's a bug in Python, more than 5 suggestions returned here. Okay, it's up to 5, could be. So if I know my code and what it does with the prompts, like the integration with them, I can create for the system something that is more, let's say, narrow, strict, because we're looking for that. The wider we have, we can accept all kinds of issues coming in. We can't be reliant on to say, well, this works, it doesn't. The more we narrow things, these are the good things, we're at a better place. So this requires something which I always talk about, for the testers to know what actually the code does, which may be a new concept. So I want to go back to the tests themselves. So you want to say, well, this is like the beginning at the beginning. What makes a good answer or resilient answer? Let's try to say, well, what we're willing to accept. Okay, so that's cool. Is it enough? Of course not. Because what are we testing here? Number of suggestions could be like the first lines from a book. So is it really a suggestion? Test suggestions. So we need to talk about the content. But for that, we need something in a way that if I give you the whole suggestion list, like I gave you this, you can look at it and say, oh, this is good, this is not bad. You kind of analyze what you're given. But like I said, we want something that is a bit more something that a computer can look at and say. Because if we can teach a computer, if we've done like 90% of it is saying this is what we want, probably we can teach the computer to check for that as well. But for that to happen, we need something called a structured response. So I'm going to switch the method. Instead of us creating the suggestions list, I created another method which does the same prompt, only returns a JSON structure, and it tells it how to build the structure. So it's a JSON object with a key of suggestions, which should be an array of strings, which is exactly what we did, only it will, I ask for 5 here. This becomes a lot more, we have an option to receive more than 5. Okay, value for each suggestion should be an array of strings, where each string is a test scenario name. Return only the JSON object. And we call it, if nothing returned, we return something, an empty list. Sometimes we have to do this kind of cleaning, because if you're asking for some kind of code, or in our case JSON, it comes up with some wrapper code. And then return the JSON and send it back. Okay, so this is basically the same thing, only the model returns the list by itself. How do we do that? Well, what does the test do? It will, like I said, this is an automation of what we'll do. What is it doing? Well, first of all, it called the get suggestion. Let's run it and see what it returns this time. Takes a while, calls the model, stuff like that. So before we go look at the assets, every time that I run this kind of thing, like I'm saying, well, will this work? It may not work. Okay, so this is what is returned. This is the JSON that is returned, really, which is kind of similar in terms of structure of what we looked at. This here may or may not be the same, even syntax of what we got. Okay, so what can we check? Well, first of all, the way we checked our list, we can check the schema here. So is it a JSON? Is it like it's a dictionary in Python? Is suggestion a key in the dictionary? If we get the suggestions, does it contain a list? Is the list not empty? Are things in the list strings? So it's the same thing that we did before, but again, this is something that you can look at and say, oh, this is not what I wanted. This is not good enough. And like everything that I kind of thinking of not good enough or good enough, or at least good enough, I can teach the computer. And now I have the beginning of sort of an automation. We can check. Okay, so yeah, that's nice, but well, we need a bit more. So what does a smoke test or a sanity test look like? Well, I'm going to use the same structured response. Okay, get testing suggestions. Remember, what you see here may not happen again ever. So I'm checking that the suggestions are there. This is that we did up until now. And one of the methods that we do is look for items in the text. So this is an option. So what we techniques that we sometimes do, get everything to lowercase because we want to do some texture search here, and dump everything into all the array into a whole string because we don't have the whole string. And then we can check if the string has user in it and to do in it, because that what makes sense. Let's see if this runs, because it's interesting. You can look for other things that will ask for testing scenarios. So maybe valid, invalid, non-existent, things that you can put, and this time it passed, because this checks that at least we have a valid, invalid, and non-existent there. So it's not just the structure and syntax of things anymore, but also valid. And it's enough that we have valid and invalid here to say, well, we're in the right direction. Doesn't tell us that this works, but more of we're in the right direction and we want to move in that direction. So let's check a bit more. What can we do? Okay, so again, same method, same request, getting the suggestions. And now we can start looking for things like this is a GET request. We know it was sent again. Okay, so let's look for verbs that are going to be in there, like verify, check, get, retrieve, validate, fetch, things that you can expand. And this is where I'm going into the prompt optimization, because you might see things and look at, this is not what I expected. Maybe my list is not full. I will add that to the list. So I can check that verify, one of them is in the text here. Again, I'm pointing it here, but this is what was a minute ago. It's not what's going to happen next. So I can check for the verify these kind of things inside the text. How many of them? This like checks that at least once, but you can actually check for all of them. Path params. This strips the ID from. Let's look at the input again. Yeah, so this strips the ID outside everything here. So this actually looks for ID in the text itself, like this thing. Okay, if there's no ID there or identifier or something like that, if there's no relevance to the parameters, then we're not covering things about the parameters. This is not good for us. Also, there are things that we don't want to appear. These are payment, product, order. These are things outside our context. So in our smoke test, in our sanity test, we said, if you find out things that you don't expect to see there, probably this is not good enough, which is exactly what we want from a sanity test. And you can take it even further. You can create like valid keywords and invalid keywords and special keywords, and do some kind like has valid, invalid, special cases. And I put some kind of condition that says that I need at least a valid case or an invalid case or a special case. I have to have at least two categories here that appear, because otherwise this is not good enough. I'm narrowing more and more what a good thing is, which is nice, but we're still on the border because we're on the boundary. This is like whether it's where everything else doesn't work, everything that gets inside our boundary is working, but is it working well? Because this is like a Boolean thing. Well, we checked out things there based on what we feel should be there, and we did a good job. But we want to benchmark, because one of the things that we want is to take three, 3,000 examples of responses and say, well, which are better? Because up until now, we haven't done that. So let's talk about grading and ranking. So let's talk about the golden dataset or datasets. We need someone, us, to say, well, what is an optimal response look like? Because if we create this, everything that the model spits at us, we can compare and say, oh, this is like half of that. It's good enough. This is like quarter of that. This is not good enough. Or maybe look at look at it as a grade. Like if it's like says above 50%, this is good. We need to somehow compare something, but we need some kind of a golden thing to compare to. Now, you might have heard about golden templates. It's an idea that as old as testing, which says like, do something compared to this golden thing. If it's the same, excellent. If it's not, there's a problem. We're using that all over the place in images, in strings, whatever. We want more than that, but we want to use the same idea. So how do we do that? Well, the first thing is actually to build this. Now, this is like a very, 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 very simplistic idea of what I want there, because like this is like four lines. I'm probably going to have in my list a whole bunch of lines are saying these are the concept that I'm going to look at and I expect to see in the responses. And then I can look at how many of them are in there and I can tell you if this is good enough or not. But I can actually test that because first of all, this test does not go to the model. I have sort of the happy path, sad path, shocked path. And I can create an automated test that corroborates completely, then this one isn't, because this one doesn't go in, this one doesn't even operate the model. I'm just going over there and seeing if things are containing the concepts. And this test tells me, well, the response is missing concept. Just going over the list to see if things are missing. And I think here something is missing. I left something out. Yeah, it doesn't have user with no to-dos here, I think. Which is okay because I'm developing this list. But once I have this thing, I can start using it. How? Well, this is an automated test, but I can do this, of course, manually. I have this list of what I expect to have in there, going to run the real model and get the suggestions from the model. But then I added a bit of code to my agent called rank testing suggestions. It will go back to the model. It will accept the suggestions that his former self returned and my golden concepts. And it will tell the model, you're an expert test analyst. Your task is to rank the following test suggestions based on their importance for ensuring API quality. Most critical are here. Here's the list of the suggestions to rank. Return a single valid JSON object with one key. Rank suggestions. The value should be an array of strings with the most important suggestions first and the least important at the bottom. Rank it for me. How smart are you? So we can actually do that. So this, for example, does the same strings and the same golden concept that I have, and send it to the structured and then to the ranking. And then you will see that it did return these suggestions, but the concepts didn't find valid user, invalid user to do. So this is like, you look at it and say, well, it's like the other things that we had until now. Yeah, but only because it didn't find some of them. And we're kind of moving towards, well, if it did find, what will happen? So this is like me ranking. Sorry, what I showed you is me ranking it because it's running this. Now I'm going to show you the AI ranking it. So this is getting the structured, and after I get the suggestion, checking that there are only 3 because I need 3 for ranking, more than 3. Get the golden concept. This is a smaller list even than that. And I'm calling the rank testing suggestions. This is going to the model and returning. And it can rank. What I ask it to rank, by the way, is the critical stuff is at least find something with non-existent ID and invalid ID. And you can see the ranking if it has -1, which I'll show you in a second while I'm running it. -1, it didn't find anything because it kind of goes over thing and looks for terms here. And then the valid cases and invalid cases. Where's my test? It's not running. So while it's running, let's look at the asserts, what I'm looking for. First of all, I'm looking for something that it found a critical thing, okay? And I think it did. Let's look at it. You see that rank of critical 0 means that it found at least 1 critical, at least 2 valids and 2 invalids, because it counted things here. And it returned, let me show you. These are the ranked suggestions. So it found at least a critical for non-existent, and I asked it to check that the critical case rank is at least in the top half of the 5. So it's going to be up there, which is, if it's critical, I want it at the top. And this is me telling the computer how to look at the list and say this is a good list or not list, or bad list. And another thing is that I want more, the valid cases are for me are more interesting than the invalid ones. So at least find at least valid rank and 1 invalid, sorry, find at least 1 valid case, find at least 1 invalid case, and I want the rank of the valid case to be smaller than invalid, which means it's higher on the list. And you can see that invalid is, I don't have a valid here. I have a valid here. Valid. No, it probably found something with invalid. And invalid is on top of something that is more valid, which the AI gave me a result that I would rank differently. So this is like the AI is not doing a good job in its ranking. And I can look at that and say, well, you know what? Maybe I need another judge. And this is where you go to another model. So same idea. I'll give my agent the work to do. So this is going to be the same thing. Only in this one will work with the Gemini 1.5 Flash, which is like the simpler model. But I also have a judge agent, which I can compare, I will help to compare the ranking with. So same code, only it will go to 2.5 Pro, which is like, let's say, a more reasonable. These are my golden concepts. I will ask the primary, my tested agent, tested model, for suggestions. It will give me something. And then I will ask it to please rank your responses. And then I will ask the judge to please rank the same thing, same suggestions, same golden concepts. And I will have benchmark ranking, okay? And now when I compare them, I can say, well, at least compared to the judge, the primary ranking must contain the judge's top suggestion. And the most important suggestions per the judge should be in the top 2 of the primary model's ranking, which is kind of going in different steps in saying this is a way to say this is a good enough answers. So a lot of ways to do this, but you can see that we're thinking differently about, especially about automation, but how we define that something is working. There are different ways to do this, different techniques to do this, and I really encourage you to work with that. Need to finish up. Let's go back to the slides. Okay, so we've seen a lot of techniques here, and we all of them are trying to help us to answer what is good enough. And we try to narrow it more and more and more. And like I said, I think testers will take more and more part in defining prompts and saying, well, this is what makes things better for us to test. Or like help us look at it and say this is working, this is not working. A lot of it is like the last things that we did. It's like sort of looking into the machine. Like if your product does some image processing, we'll still need to see what is working, what is not, and what is a good result and what. And sometimes we'll need to do the same thing with the prompt to look at what it brought to us, like a blob or binary array, and see if things are working. We need to define what is working and what is good enough. And we can do this like all I showed you is like something that works on a specific invocation. You can do this like in different ways. You can do this systematically, like look at the results of different runs because this is indeterministic. You'll get a different result every time. Look at it over time and take statistics of what you see. And you can say that statistically, 60% of what we've seen is good enough. You can look for bias. Okay, not the one that you're thinking about, like bias valid and invalid cases. You can look at what we're getting back, and you can see that more and more thing we get invalid cases. We can use that to tweak the prompt to give us something that we want if we don't want invalid cases. But the basis for that, like I said, is that we need to make sure our code works first and then do the whole thing. Otherwise, we can't really know what's going on in there. So we've seen a lot of things, and I think that this is like the beginning of what we're seeing as ways and techniques of testing this stuff. This was introduction. Next time, the next webinar I'm going to do, which is going to be more than a month, I'm going to dive more deeply about testing an agent in different techniques and show you more examples of that. I think we're going to see a lot of changes in how we're testing today because, like I said, testers are going to go into prompt optimizing and defining what is actually working, what is not working, and this changes our way of working. I think that this will lead in turn to better specifications and specification as a sort of in a BDD way, automated specifications, because it will lead for us defining better, more strictly what is a working thing. So again, this changes because before it was like translated to a single assert. Yes, now we need different way to explain something is working. We'll need to learn how to do this, how to define this. And I think this is going to be a cycle and part of the tester's job as well in the future. Like I said, this is the intro. I'm going to do a lot more webinars about these things and more techniques. So stay tuned. If you have questions, please put them in the chat box now. How to cope with the flakiness of such tests? Yeah, this is not going to get away. We're not going to break away from this. So I showed you a couple of ways to deal with that, and it's not 100% proof. Like trying more resilient stuff, more things about what makes a broad good answer rather than or assert rather than or what is definitely a bad answer, but they are going to be flaky. So the first of all, the dealing with the flakiness is first of all separating the code, making sure that our code works. So at least we can test things inside the model, knowing that our code is not flaky. And there's a lot of these things going into the thinking and strategically thinking of how we're going to test that. It goes into the code, goes into the definition of what is good enough, what is bad enough, not good enough, and trying to narrow as much as possible what is good. So yes, I hope that answers the second question as well in the chat, which is what I showed you today. This requires some skills that we weren't born with. Prompting. We'll need to learn good things for us that we may or may not do today, or some of the things that we do without thinking, saying, this is good, this is bad. We'll need to define and communicate what is good and bad. So if AI is looking for testers, I think that the testers will find them eventually and return fire. Okay, thank you for coming today, and see you on the next webinar. Bye-bye.